All right, so in order to do 19b, I still have to do A. I suppose I don't have to solve it separately. I could just probably plug in the values in there, and I think I'll do that. If I wanted to solve just for B, I would do this. It says a 45 RPM record has a diameter. Now also make sure whenever they say, sometimes you need diameter, sometimes you need the radius. So if I need the radius, I have to remember to divide that by 2. And they're giving me the mass. Assuming the record to be a thin, uniform cylinder. So I'm going to use the formula for a cylinder. Determine, and when they say a disc, because some of the problems say disc, a disc is also a cylinder. Like a record is a thin cylinder, a disc is a thin cylinder. So the question says the angular momentum of the record when it's moving. I'm going to do this going right to part B. I'm not going to even solve for part A separately, since somebody asked me to solve for B. So if I were solving for B separately, I know that the formula for L is I omega. That's the formula for angular momentum. So all I need to do is put in those two numbers. Now for I, I'm going to replace the I with the formula for the moment of inertia of a cylinder. And what's that formula? 1/2 mr squared. So that's going to be 1/2 mr squared. Now they did give me, they are telling me it's a 45 RPM record. I can get my L in terms of M and V if I want. Okay, so I could do that. But let's just keep it as omega. So times omega. Because I have all those numbers there. I have the mass of the record. I have the radius of the record. And I can get the omega. Now, what do the units have to be for omega? Radians per second. So you have to do a conversion. So I'm going to take 45 revs per minute. And I'm going to convert that into radians per second. And then I'll have everything I need to plug into that equation. So I'm going to go revs to radians and minutes to seconds. 1 minute is 60 seconds. 1 rev is 2 pi radians. So working that out, what do you get for the angular velocity? Now my units for angular momentum, does anyone know what the units will be for this? Look up here. Look up here. What do you think the units are going to be? Now the units for regular momentum are just the units for mass times the units of velocity. So regular momentum, P, would be kilogram meters per second. But it's different for angular momentum. What would it be? Well, the radian, that's the unit that we don't even have to put in there. We can sort of ignore it as a unit. But I have a kilogram, meters squared. Again, you'd say radian per second, but really the unit is a kilogram, meters squared per second. That's what you get for that. So does anyone have the angular velocity here? What is it? 4.71. So just plug into that, and we'll have the answer for angular momentum. So L is going to equal, L is going to equal 1/2 m r squared omega. So for omega, 4.71 radians per second. The mass in the problem was 0.095. And the radius would be half of 0.210, so that's going to be 0.105. And that will give you the angular momentum without me separately solving for the moment of inertia. And on the test, like I told you, on the test, I might ask you the B question or I might ask you the C. Now look at the C question. It's very similar to the B. The difference is that K, the rotational kinetic energy, would be 1/2 I omega squared. So it would still be based on those two variables, I and omega. You're just plugging into a different formula. So what does this answer come out to be for angular momentum? Hopefully it's, is it 2.47 times 10 to the negative 3? So 2.47 times 10 to the negative 3 kilogram meters squared per second. Again, there's a radian, but we just ignore that as a unit because it's like that fake unit that helps us go from something angular to something translational. Any questions? All right. Do you need me to do